YouTube, welcome back. Today we continue our series of JavaScript fundamentals. JavaScript fundamentals, it's a new series at Leetcode, and I guess I thought that it is pretty interesting to solve this one. So this problem today we'll talk about something called the function composition. Um, let's read the problem and let's after that know what is a function composition and what is the importance of it. This one. Given an array of functions called f1, f2, f3, and so on, return a new fn that is the function composition of the array of functions. The function composition of this array of function should be fx. The fx equals f that calls g that calls h. The function composition of an empty list of function is the identity of function x equals x. We may assume each function is in an array accepts one integer as input and returns one integer as output. So for example, if x equals 4, so we have 4, we add it to 1, we add it to the other, we add it to the 1, we get 65 if you look at this array. So before start solving this problem, there is two important things that we should talk about. The first thing that we want to talk about what is a functional programming. Functional programming, and what is functional? Oh, I typed function wrong. And what is functional composition? Okay. So because this one is a part of this other one. So let's start with functional programming. So a functional programming is a programming paradigm that focuses on the use of pure function and immutable data to build the programs. It treats computation as the evaluation of mathematical functions and emphasizes writing code that is declarative, modular, and avoids mutable state and side effects. So right now we know what is functional programming. There is some key principles and concept associated with the functional programming. I will just mention the headlines of them, and there is only one of them that I will just take deep of them. We have something called the pure functions. We have something called immutable. The third one is high order function. The fourth is recursion. The fifth is avoiding mutable state. The seventh is purely functional data structure. The sixth, which is what we're talking about today, the function composition. And the function composition is a fundamental concept in the functional programming where two or more functions are combined to create a new function. It involves taking the output of the function and using it as input for another function in a chain. It's some sort of a chain. If you look at this example, it looks like a chain, like F, G, H. All of them looks in like they are in one chain. Basically we're allowing for creation of more complex operation by combining simpler functions. The result of function composition is a new function that performs a series of operations in a declarative and modular manner. The output of one function becomes the input of the next function, forming the pipeline of transformation. In a functional programming, function composition is typically achieved by using what we call the high order function. If you don't know what is a high order function, I created a video about what are high order functions. So make sure that you just review all the previous video that I talked about, because I talked about the high order function in one of them. We basically, in the high order function, we can accept function as arguments and return the other functions as results. By leveraging high order function, we can create composable and reusable code. So let's just take an example, and I would love to just talk about this example. Let me copy the code, because I don't think it's a good idea to just try to write the code from scratch, because it's a lot of code. So in this example that I have here, we have three functions: add one, double, and square. Okay, and basically we have a composition function that want to use all of them. So the composition function combines these functions in a specific order to create a new function. It adds one to the input, then doubles the results, and finally we square the results. When the composed function is called within, like for example, a 3 input here, we will get the results will be 64. It goes through the function add 1. So we add 1, it will be equals 4. We double it, it will equals 8. After that we square it, it will equals 64. So function composition provides a way to break down complex operations into smaller ones, reusable functions. It promotes code it promotes code modularity, readability, and reusability by separating consoles and allowing for combination of function with specific behaviors. So by leveraging function composition, we can basically build a pipeline of operation that transform data in a clear and concise manner, making our code more declarative and easier to be understood. So right now we know what are functional composition and how can we use them. So let's start to build the code. Let me just first delete the example, because I guess we don't need it anymore. And let's go to this one. So in this one, first of all, I want to check if the array, because they said that if the array is empty, then I will return x directly. So if the functions dot length equals 0, I will return x. This is one edge case. Okay, let's just start to let's create an input variable. Let's call it input, because each function takes something we call input, and this input will equals x at the beginning, as we said. We create a for loop, and instead let I equals functions dot length -1. We start from the end. I is bigger than or equal 0, and I minus minus. Because if you look at this one, we start look at this one. We have fx, fg, fh. We start with fh, and after that we're wrapping everything with it. So we start with the end. So let's say that we have const the current function, and it will equals functions of I, and when we have the input will equals whatever comes from the current functions, and we give it the input as an argument. I know it looks quite weird to understand this one, but like and after that we return the input. But just try to understand that just if you did do the function as a normal variable, you will understand everything. So for example, let's just take a deep look at this one. So we have the current function that equals functions of I, and it's just a function, and we just send an input, and we just try to loop, and we just try to update the input over and over and over and over, and you start from the end to the beginning. Because if you look at this one, you start from the end to the beginning, because when you call fg, the f called g, the hg called h. When h returns value, the g returns value to f. So because of that, we start from the end, not the beginning. No, thank you, I don't want that. So let's talk about, okay, it beat only 90, 59. How much was the person? It wasn't big, basically, just only 20 milliseconds. It wasn't that big. So that's it for this video. I hope my solution was quite good. If you like my content, make sure to subscribe and hit the notification bell so you will never miss a video. If you didn't like my content, make sure to give me a comment to tell me what exactly you didn't like about, so I can improve myself over and over. So that's it for today's video, and see you in future problems.